Okay, in this question we're working with reflections, specifically reflections about the x-axis. Let me go through the question very quickly. We're asked to graph y equals x minus 3 all squared, and we want it reflected in the x-axis. So there's our x-axis, there's that curve of y equals x minus 3 all squared, there it is right there. We're going to reflect it in the x-axis, and it's going to be a mirror image down below over here. And the way we're going to do it is in two steps. The first thing we're going to do is we're going to transform this using this little trick I'm going to show you in a moment, the formula, and we're going to transform it into the reflection graph down here by applying it to this equation. Then we're going to take the new equation, the one that's reflected below that graph, and we're going to use a table of values to find the exact points so we can plot them on the graph down here on the number plane so we can actually get an image of it. But another way to do it is just take the points from the top one and just translate them down below. So for example, if we got the point 1 across up 1, then we just go 1 across down 1. And if we go 2 across up 4, then all we have to do is go 2 across down 4, and so forth and so on. That's another way of doing it. But we're going to do it these 3 steps to give you more clarity on how to do this. So here's our function right there, y equals x minus 3 all squared. Now the shape is a parabola, as you can see right over there. Let me just mark it in. That's y equals positive x minus 3 all squared. There it is right there. There's the parabola, it touches at positive 3 there. It's the opposite, that's a minus 3, it's a positive 3 right there. Let's get the mirror image down below. So the first thing we've got to do is use this particular transformation technique here. To reflect in the x-axis, about the x-axis, let me just put an arrow here, about the x-axis, all you have to do is replace the y for negative y. In other words, the y is going to equal negative. You just put a negative in front of the function x. All we're doing is put a negative in front of it. So let's take this guy and put a negative in front of it. So now y equals that, so negative y is going to equal negative, that bracket, just copying it down, x minus 3 all squared. So there's our reflected image graph down there. That's the equation. Now all we have to do is take that equation, take that function, and substitute in our table of values to confirm the location up here on the number plane. So let's go ahead and do that. So the way to do it, I'm going to graph this one and this one at the same time so we can confirm all the points. So let's go ahead and do that. So to top it off, I'm going to have the x values. Then I'm going to have these values, the parabola that's concave up, and then the concave down parabola. So the concave up, this one here, x minus 3 all squared, and then we're going to have this one here, negative x minus 3 all squared. So let's put in some lines here. I'm not going to put in too many points, just the bare basics. So let's put the points 1, because we're going to this side of the parabola. So I'll go 1, 2, 3, 4, and probably 5. Okay, let's start to see how we're going to do this. So we're going to substitute x equals 1 into the first function, which is the one here, which is the one that's concave up, and just confirm the points we have there. So we got x minus 3. I take a 1, I replace it for the x. 1 minus 3 is going to give me negative 2. Negative 2 all squared, negative 2 times negative 2 is a positive 4. So all we're going to do is put a 4 here. Then we're going to take the 2. 2 minus 3 is negative 1. Negative 1 squared is positive 1. 3 here. 3 minus 3 is 0. 0 squared is still 0. Here's the 4. 4 minus 3 is 1. 1 squared is 1. And the 5 here. 5 minus 3 is 2. 2 squared is 4. Now we're going to do the mirror image. The reflected graph is minus x minus 3. I'm going to take the positive 1 and put it here. 1 minus 3 is negative 2. Negative 2 all squared is positive 4, but we have a negative in front of it, so it's going to be a negative 4. So they're all going to be negative. So I'm going to take a 2, put it in there. 2 minus 3 is negative 1. Negative 1 squared is 1. Positive 1, so put the negative in front of it, so that's also negative 1. 0 in there is just going to be 0 minus 3. Minus 3 minus 3 is 0. 0 squared is 0. That still stays 0. And then we got 4. 4 minus 3 is 1. 1 squared is 1. Put a minus in front of it. And we got a 5. 5 minus 3 is 2. 2 squared is 4. Put the minus in front of it. It's negative 4. So as you can see, we've got the exact same numbers, same points, except on the bottom, they're all negative, meaning they're all going to be located down here. So let's plot the points down below to see the mirror image. So down below for this one, we've got minus 4, 1 minus 4. So 1 minus 4, 1 minus 4 will be about there. Then we'll have 2 minus 1. So 2 minus 1 will be there. We have 3 and 0. That's the point already here. So I'm just going to put a point there. That's already there. And then we're going to have 4 minus 1. 4 minus 1, that'll be there. And finally 5 minus 4. 5 minus 4, that'll be right there. So the graph's going to look like this. So there's the graph there, and I'll just put in the points again. There's the point there, a point there, and we have a point there. And as I said earlier, another way to get that mirror image is just to copy what's there and just translate it down. So if we go across 1, up 1, we could go across 1, down 1. We could go across 2, up 4. We could go across 2, down 4 and get the same mirror image. So there's our graph for the mirror image reflected about the x-axis. All you've got to remember is that when you're reflecting on the x-axis, remember to replace y for negative y, where you get a negative in front of the function. So I'll just write in this function here. Negative. And we lost our point there. I'll just put it in right there. And there you go.